Please turn off your mic. CUOT Janam. Okay, so good evening, everyone. Welcome to the week 9 of problem solving session on industrial wastewater treatment. Uh, as usual, we meet every Tuesday from 6 p.m. to 8 p.m. via Google Meet, and the recording of this session is being uploaded on this YouTube channel, the link for which has been already shared with you. So in week 9, we have talked about this textile and dye and fertilizer industry. This textile, whatever the wastewater produced from textile industry or dye industry and fertilizer industry. So different environmental impact from these industry, and how uh, if once the wastewater is generated, how those wastewater can be treated. We will be looking into, we have looked into uh, video lectures. Okay, so this was completely theoretical topic. Everything, if you have gone through the lecture, you might have noticed that everything they were dealing only four thing: how the which type of wastewater is produced by the production of this wastewater, what is the different impact on the environment, and how those wastewater can be treated. So these were overview, and there were no numerical. So in this particular problem solving session, I have gone through the questions, many questions, and all those questions are theoretical question only. Okay, so we will be looking into those things. So before going into this, as usual, a brief discussion about the previous week, and then sorry, a brief overview of the lecture of week 9, and then problem solving session. Before going to that, I want to ask that there were few concerned about the marks not assigned in, I think, in week 4 and 5, and there was one, I think, in week 7 or week 6, a stern problem. So are those problems resolved, or it is still there? There were few complain that in spite of marking correct answer, you did not get marks. So are those problems solved, or it is still there? Did you get your marks? Okay, I think if you are not saying anything, then I assume that it's the problem has been solved. If the problem has not been solved, please let me know. I will be writing them to again so that they can take this thing in Excel. If not, then I am moving forward. So in this topic, we were dealing with textile and dye and fertilizer. In textile industry, wastewater, we know that textile can be of many things. The major one are cotton, wool, synthetic fibers like polyester, nylon, and rayon. Okay, now a brief introduction about this industry has been given, and from the name itself suggests that the industry deal with cotton, wool, and all these things. Okay, so there are many process involved in production of cotton or wool or synthetic fibers, such as spinning, that is drying, then weaving, then weight processing is there. Sorry, weight processing is there. So during production, a huge amount of waste is produced. Okay, and major pollutants are dye. Okay, now so we know that we have to color our cloth depending upon the demand and all this thing. So during dyeing process or bleaching process, a huge this is as this is a weight processing, so it involves a large amount of water. And what happened that huh, what happened that during this weight process, a huge amount of wastewater is produced, and the major pollutants are dye. Some of the chemicals are also used, such as sodium hydroxide, detergents, it is like containing a longer chain of molecule, and some phosphate and other things are also there. Then bleaching agents is there. Then heavy metals such as chromium, cadmium. So these are some of the coloring agent which are used, and once it is dissolved in water, it remains in the water. If not treated well, this can go in the wastewater, and it will impact our environment. Okay, and also we know that these cotton and wool may contain a high amount of organic matter also. So there are as organic matter are present, so there will be high COD, BOD, pH will be also there, suspended solid will be also there due to the presence of detergent, bleaching agents, and all these things. Suspended solid can be due to of many things, undissolved metals, or due to presence of some unfurnished cottons or wool or anything. Okay, so these are the uh, these are the few problems which arises due to textile industry. So we have to treat these wastewater. So there are many treatment methods, such as physically there. Suppose we want to remove the suspended or larger particles, then physical screening is there. Then we have chemical coagulation for flocculation. Here we these are normal things that we use alum and FeCl3. Then adsorption with the help of activated carbon. Some of the pollutant can be removed by adsorbing on activated carbon. Then we have electrochemical also, like these are different, like depending upon the type of pollutant or type of wastewater, we use this different type of method. Okay, then we have biological, then we have membrane technology. Then in woolen textile industry again, same thing is there. We have first is like we have to it goes through different process like removal of wool grease. Then there is a carbonizing, that is acid treatment, and finally dyeing, and then finally finishing. So doing these things, a huge amount of wastewater is also produced, and the wastewater composition have very high pH. A high organic matter is there because wool is raw material is full of organic matter. Then there is suspended solid also due to presence of reagents that is used during the making process. Okay, Again, you can see that it has high BOD, biochemical oxygen demand, means like it contains high amount of organic matter. So now imagine that if you have dumped these in wastewater, suppose in river, so what will happen that it will consume all the oxygen present in the river or lake. So eventually what will happen that it will, the water where it has been dumped will contain a uh, low amount of oxygen, and that will be harmful for the aquatic life. Toxic dye and heavy metals affecting the aquatic life. Again, this toxic dye and heavy metal, means like these heavy metals it itself a toxic to, like suppose there is a chromium or something, so it will eventually affect the aquatic life and all these things. Toxic dye also like generate some kind of color and all these things, so in that way it harms our aquatic life. Hmm. Then we have synthetic textile. This is the currently largest this synthetic textile industry is at boom. Many people, many things you are seeing that all things are textile, synthetic textile thing only. Okay, now many clothes and whatever we are wearing is made of synthetic textile only. Okay, now so here again there is a process, and you can see previously like here two kind of waste depending. I think there are two process where two kind of waste is produced. One is acidic wastewater is also produced, and basic, that is alkaline wastewater are also produced. Some of the, like here in this method, we there is a use of zinc sulfates and carbon dioxide sulfide for different process. If you have gone through the lecture you might have idea like what is the use of these pollutants, not pollutants, sorry, what is the use of these minerals in this process. Okay, so eventually as this is here also there is a utilization of what wastewater, sorry, what do we call water, and eventually these are dissolved in the water and eventually come as a wastewater containing high amount of zinc and sulfates. Again, for as it contains zinc, then it can be removed by precipitation or ion exchange, pH adjustment, coagulation, and biological methods. Finally, there was a short discussion of fertilizer industry. So we know that fertilizer mainly contains a huge amount of nitrogen. Okay, nitrogenous fertilizer, that is urea, ammonium nitrate, and ammonium sulfate. Okay, now so there is like process of ammonia synthesis, that is Haber process, then urea formation. So here the wastewater, as you can see that a huge amount of ammonium is used. So obviously the wastewater which will be generating will contain high amount of ammonia. Apart from apart from ammonia, phosphorus is also used in. If you have heard of fertilizer, it is NPK, nitrogen, phosphorus, and potassium. So it contains high amount of phosphorus also, and phosphorus is in the form of phosphate. And the phosphate which is coming in the wastewater, the phosphate solid which comes from fertilizer generally contain fluoride also. So you can see that fluoride is also the wastewater which will be there will contain high amount of fluoride also. Apart from fluoride, there is arsenic also. Okay, all these are very toxic to aquatic life and cause eutrophication. We know that the high amount of phosphate can lead to eutrophication because it is a food for algae, and algae consume this phosphate and it turns green and finally causing eutrophication. Treatment method is there, ammonia removal is there, steam stripping, and ammonia like a steam stripping. We have seen what is this stripping removal depending upon this k value, Henry constant, and all these things we can strip out the ammonia. And ammonium is like it can be converted into gas and all these things. Then there is a lime coagulation for phosphate removal and fluoride removal. Means like if Lime is if you add calcium, then if high amount of fluoride is there, calcium will react with fluoride and it will form CaF2 and it can be precipitated. Then nitrification and denitrification for nitrogen removal. Then this was about this nitrogenous fertilizer. Then we have phosphatic fertilizer here also. Okay, now so when we talk about nitrogenous, there all three material will be present, nitrogen, phosphorus, but amount of nitrogen will be higher. Similarly, in this case, phosphatic fertilizer, amount of phosphate will be higher. Nitrogen will be also there, but it will be in lesser quantity as compared to this phosphate. Okay, reaction of phosphate rock with sulfuric acid, phosphoric acid, again it will contain high amount of fluoride because this phosphate rock will contain some amount of it. Is generally see that has been seen that this phosphate mineral containing phosphate also contain fluoride and all this thing. Okay, fluoride, phosphate, sulfuric acid and heavy metals is there. Again, as we are using rock, so there will be some other heavy metal also like chromium, cadmium, zinc, iron. Then treatment fluoride may be removed by lime and alum flocculation. Again, this what happens that this aluminum is when aluminum reacts with fluoride water, it forms AlOH, aluminum hydroxide, and aluminum hydroxide is a kind of PPT precipitate where this fluoride can get attached on the surface of this uh, alum flocculation. Okay, wastewater neutralization before discharging. Here is also there is a range of pH. So we have all these things, impact of this type of wastewater we have already seen: toxic, eutrophication, corrosion, carcinogenic. So we have to treat it. These the sixth point is saying that we have to treat this wastewater, else it will cause this problem. Okay, so this was just a small overview. So this if anyone have any doubt, you can say write in chat box, or you can unmute yourself, you can say, or I will be proceeding with the question and answer. And again, this topic is fully theoretical topic if you have gone through the lecture, so that's why they means I have tried to like I have given one numerical question, but that is like previous session question only data has been changed. But so uh, completely theoretical topic it is. I will request everyone to please participate. Chat box is open for everyone. Anyone can write anything. Okay, so if no doubt, can may I proceed further? May I proceed with question answer? Yeah, if anyone has any doubt, you can write in chat box. Okay, so this is the first question. Nylon cloth is made of. Very easy question. Anyone B, synthetic fibers. Others? Yes, the correct answer is B, that is synthetic fibers. The nylon is a synthetic polymer made from petrochemical. It was developed as an alternative to silk and produced through chemical process called polymerization, specifically condensation polymerization of diamine and dicarboxylic acid. Nylon fibers are known for their strength, elasticity, resistance to abrasion, making them widely used in textile, ropes, and industrial applications. So yes, the correct answer was this synthetic fibers. So currently, whatever the clothes we are seeing are mostly synthetic clothes, and that is made of nylon clothes and all these things that is made of synthetic fibers, and that is made through the chemical process. Then we have natural fibers. We have seen natural fibers are cotton, jutes, wool, silk. Okay, then we have cellulose fibers. This is also incorrect because cellulose fiber derived from plant. plant source such as cotton and rayon, which is made from regenerated cellulose. Okay, now these all are naturals. Then we have protein fibers. Again, it is incorrect because protein fibers come from animal source such as silk, silkworm, and wool from sheep, which are made of naturally proteins like fibrone and keratin. Nylon is not protein based, but it is purely synthetic. So yes, the correct answer was B. Coming to question number two, gassing process during manufacturing of cotton textile refers to C. Okay, anyone else? Anyone with another answer or same C? Yes, the correct answer is C. The gassing process in cotton textile manufacturing refer to singing, which is um, is, huh, which is a process of passing the fabric or yarn over the flame or heated plants to burn off the loose fabrics or uh, fudge. This process gives the fabric a smoother and cleaner surface, which improve its appearance and quality. It is typically done before dyeing or printing to ensure uniform coloration and refined texture. So yes, the correct answer was C. So I think these are direct question about other process. What is slashing? Slashing, also known as sizing, the process of applying protective coating to wrap up the yarns before weaving. This improves the strength and reduce the breakage during the weaving. This does not involve burning of the fibers. Okay, so burning is only done during the gassing phase, but this slashing is entirely different thing. It's like applying a protective coating. Okay, then we have a scoring, is a chemical washing process that removes the natural wax, oils, and impurities from the cotton. We know that there will be natural wax, oils around the cotton, and we want to remove it. So that is done by this. That is done with the help of some equipment or some chemicals, and the process is known as scoring. It helps in improving the dye uptake, but it so this was also not. Then we have mercerizing, is a chemical treatment using sodium hydroxide that increase the strength, luster, and dye adsorption of the cotton fibers. Okay, and then dyeing, we all know that it is applying color to the textile using various dye. It comes much later in the textile processing chain and does not serve the purpose of removing fuzz and loose fibers. So is the correct answer was C. Question number three. The term carbonizing is used during the manufacturing of B. We got one answer, that is B. Woolen textiles. Anyone else with any other answer? Yes, the carbonizing is a chemical process used in manufacturing a woolen textile to remove plant-based impurities such as cellulose, seeds, and grass from the raw wool. Okay, na? So this process involves treating the wool with sulfuric acid or another strong acid which destroy the plant-based contaminants while leaving the wool fibers unharmed. After the acid treatment, the wool is heated and washed to remove the degraded impurities. This process improves the purity and quality of the wool, making it suitable for dyeing and further processing. Okay, now. So yes, the correct answer was B, woolen textile. Here we want to like this raw one will contain many things, um, like some cellulose seed, and we want to remove. So one is the that we add appropriate amount of acid that will make sure that only those cellulose seeds and grass are being removed. Other original wool remain as it is unharmed, so that can be used for further processing of dyeing and further processing. So this the process is known as carbonizing. Cotton does not see about cotton textile does not require carbonizing. Instead, cotton undergoes like scoring, bleaching, and we have already seen this thing. Okay, now textile fiber are not man-made and do not are man-made and do not need contain natural plant-based impurities, as synthetic one does not contain any natural impurities. So there is no need to adding any chemicals like acid and all this thing to burn off those things. Semi-synthetic again same thing. There is no need of such addition of chemicals and all these things. So correct answer by B. For production of synthetic clothes like nylon, synthetic yarns may require anyone. For production of synthetic clothes like nylon, synthetic yarns may require anyone. What happened? Light scoring. Okay, now synthetic on the correct answer is B. That is this. Let's see why. Okay, now synthetic yarns such as nylon and polyester are manufactured from pure chemicals compound, meaning they do not contain natural impurity like wax, pectin, or oils found in natural fibers. However, they may have some processing, lubricant, spin finishes, and anti-static agents applied during the manufacturing. Therefore, they require only light scoring to remove those minor contaminants. Okay, now so we know that what is scoring, like removing the impurities from the material. Okay, now so again, as we know that the synthetic one does not contain any natural impurities, but it might contain during its production. It might contain some kind of problems such as lubricants and all these things. So we have to remove those things before the final finishing process. Okay, now so for that process is known as light scoring. Okay, I hope this is clear to you. This is incorrect. No scoring by synthetic, but it still contains some of the finishes problem. That's why there is a need of a scoring. Then high scoring again. This is done in like natural things. Like uh, we have seen like to high scoring are carbonizing and all these things. Okay, na, in wool textile we have seen that we have to remove the naturally occurring uh, material impurities present in our material. Okay, na, so natural fibers like cotton and wool require high scoring to remove natural waxes, pectin, and oils. Okay, so the correct answer is correct answer is what? This B. Okay, now then we have double stage scoring. If you have gone through the lecture, you might have seen that if our raw material contain highly contaminated with natural fibers, then again in that case we have to do double stage scoring. Okay, so the correct answer was B. Only a small amount of scoring is done so that little amount of impurities which is present there can be removed. Read the question properly and try to answer it. Wastewater produced from the production of synthetic fibers can be treated by. So first you have to know what kind of waste is being produced from the synthetic fibers. Okay, now depending upon that you can treat it. So treatment can be done. Can be done by biological process. Biological process only if it contain high amount of that. Does this synthetic one contain high amount of biological process? First you have to know this thing. Okay, na. Second, mixing with the domestic wastewater and treating by conventional method. So you can always say that why not? Because in our hometown, yeah, in our city, we have always a domestic wastewater production from our house and all these things. So can we mix our wastewater produced from the synthetic to this line and we can treat it? Another option. Second, third option is dilution, neutralization, and addition of phosphoric acid, and fourth option is adsorption process. So See, so anyone if that is 2 and 3, 2 and 3 mixing with domestic and dilution. Yes, that is correct, I think. Yes, correct. 2 and 3 mixing with domestic water and treating it conventional process. And second is these are two methods are generally discussed, suggested when wastewater from synthetic textile industry is produced. Okay, now the wastewater generated from the production of synthetic fibers contain chemical pollutants such as dyes, surfactants, solvents, and organic compounds, which are difficult to degrade biologically. Therefore, the treatment method typically involve physical and chemical process. Okay, now you can see that because there is no organic matter and all this thing. When we do biological thing, when there is a amount of organic matter, then we use activated sludge process, or what do I call, trickling filter and all this thing. But as we know that it contains only dye surfactant, so there is no need of any biological. Okay, so biological process incorrect. Biological treatment like activated sludge or anaerobic digestion is not effective for the synthetic web because it contains toxic and non-biodegradable organic matter, non-biodegradable chemicals. Okay, now that inhibit microbial. However, if synthetic water mixed with domestic water, the organic matter in domestic water can support the microbial making biological. So this is another thing. This is another condition. But in general, biological treatment cannot be done. Okay, now mixing with the domestic wastewater and treating by conventional process. When synthetic water is diluted by mixing it with synthetic sewage, the concentration of toxic is reduced, making it conventional treatment method more effective. Okay, so this thing, this is one option. Dilution, neutralization, and addition of phosphoric. Yes, neutralization required because synthetic fiber may generate acidic or alkaline effluent. We have seen it can produce acidic also, and it can produce alkaline also, which must be balanced before discharge. Dilution helps reduce the toxicity of concentrated industrial wastewater. Phosphoric acid is often added to adjust the pH, provide essential nutrient for any biological treatment that may follow. Okay. Then we have adsorption. Can remove certain pollutant, but it is not complete treatment method for synthetic wastewater. It is mainly used as polishing step to remove remaining organic contaminant after primary treatment. So the correct answer was 2 and 3. That is F. Which of the following metal can be recovered from viscous rayon wastewater? C. Zinc. Zinc. Two answer. C. Okay. Yes, the correct answer is C. That is zinc. Viscous rayon manufacturing involves the use of zinc sulfate. So again, obviously, if zinc sulfate is used, then zinc will be in the wastewater in a spinning bath, which helps coagulating the cellulose janeth to form fibers. As a result, zinc is a major contaminant in. Obviously, if we are using zinc sulfate, then there will be some of the zinc will be remain in the dissolved form, and it will be flowing with the wastewater. Okay, so that can be recovered. There are several processes such as precipitation, electro ion exchange, electrolysis, or adsorption. Okay, now so these are not, the other option were not correct because this arsenic is not used in this industry. Nickel is used in another industry. Cadmium is also not is used in here, but it is generally used in dye industry and all this thing. Okay, now copper again incorrect, so zinc is the correct answer. Carbon dioxide produced from the CO shift converter effluent can be separated by using which of the following chemical slash physical solvent? E. All of above. Um, E. The correct answer is E. All of the above. Carbon dioxide CO2 is commonly separated from the CO shift over effluent which contains CO2, H2 and other gases using chemical and physical. Each of these solvent is used. Means yes, all these solvent are used. How these are used? First is monoethanol amine, methanol, MEA, monoethanol amine. Is widely used amine based chemical solvent for CO2 capture. It forms a reversible carbamate reaction with CO2, making it effective for gas purification. Commonly used in natural gas processing and flea gas treatment. If you have gone through the lecture, I think there are some chemical reaction also written based on these things. Okay, now, so I will suggest go to the lecture notes and you will get it. Okay. Then again diethanol amine DEA, similar to MEA, DEA another amine based chemical solvent that absorbs CO2. It has lower reaction rate than MEA but is more stable and consume less energy for regeneration. Then potassium carbonate, that is K2CO3. The hot potassium carbonate process is used to remove CO2 effectively. It is widely applied in synthetic gas treatment and ammonia production. It works via carbonate bicarbonate equilibrium reaction with CO2. Okay. Then we have physical solvents, that is glycol dimethyl ether. Okay. So this is a physical solvent that absorbs CO2 under high pressure. Uh, if it is commonly used for syngas and naturally, so these were some of the like method by which these observes um, uh, CO2 or separate CO2. So the correct answer was E, that is all of above. So if you want to know more about these option, you can always go to your video lecture and you will a huge this has been discussed in very detailed manner. Question number 8. Urea can be produced by reaction with NH, ammonia and CO2 in the molar ratio of B. Good. Yes, the correct answer is B, 2 is to 1 for ammonia and bicarbonate, and this is the reaction which is there. Urea, this is produced by the reaction of ammonia and carbon dioxide in Haber-Bosch process, which takes place under high pressure, and the overall reaction is 2 mole of ammonia react with 1 mole of CO2. It forms ammonium carbonate, and this ammonium carbonate uh, is finally giving us urea and water. Okay. Step 1, ammonium carbonate reacts carbonate carbon dioxide react in 2 is to 1 molar ratio to form ammonium carbamate, and ammonium carbonate decomposed to produce urea and water. The molar ratio of NH3 to CO2 required for this production is 2 is to 1. Yes, this is correct. The major pollutant concerned in the wastewater emerging from the phosphate fertilizer plant is very common question. A. Someone is saying A, someone is saying C. Chlorine, chlorine, is not chlorine. C. Yes, correct answer is C. That is fluoride. If you recall during the recap, I was saying that this phosphate rock contain fluoride also. So when these are processed, some of the fluoride also get dissolved in the water. Phosphate fertilizer generated from the wastewater contain high as a major pollutant. Why this raw? See here, you can see Raw phosphate rock used in fertilizer production contain significant amount of fluorine compounds. You can see fluoroapatite, calcium 5, phosphate 3, and fluoride. So now if you dissolve, if phosphate is being extracted for fertilizer, then where will this phosphate go? Where will this fluoride go? This fluoride will go into the water. Okay, so a high amount of fluoride will also generated during acidulation process. Reduction with sulfuric acid to produce phosphoric acid. Fluoride is released in the wastewater from the wet process phosphoric acid plants and fertilizer production often has high amount of fluoride concentration. I hope you have understood. The one who has answered A, neage, neage. Okay, which can be toxic to aquatic. This aquatic life, this fluoride is toxic to human, toxic aquatic life, and all this thing. Okay, now this chlorine is incorrect. Chlorine is not a major pollutant in phosphate fertilizer plant. It is more common in industry like bleaching and all this thing. Okay. Then other option was chromium. Chromium is also not here. Can anyone say where this it's already written here. In last lecture where we were discussing about this leather industry, then we have seen many problem with chromium. Leather industry use chromium, basic chromium sulfate and all this thing. Copper is again another thing. So fluoride F minus is a primary pollutant. Okay. Two-stage lime treatment is used to remove the which of the following contaminant present in water emerging from complex fertilizer plant. So one is already we have seen this thing. For fluoride is also is there. Two stage means in two stage one of the contaminant in fertilizer industry is fluoride. Which one is another one? E, we got insert E 2 and 4 phosphate, and G 4 and 5, 4 and 5 arsenic is arsenic. See, we are talking about this lime process also. Two-stage lime process. So can lime helps in arsenic removal? And you might be saying with respect to this thing that this in complex fertilizer plant we have production of arsenic also. Means if raw material contain arsenic, it will get released. Let's see the answer. The correct answer is E2 and 4. See, it will contain our rock. We might contain arsenic, but the question is, can now the second thing is that can arsenic be removed by lime process? The answer is no. We cannot remove arsenic by adding lime. Lime is calcium hydroxide. Calcium do not generally react with arsenic and form something. But this phosphate or fluoride react with calcium and it forms calcium phosphate mineral, and fluoride forms calcium fluoride, that is known as CaF2. Or in presence of other things it can react other form other thing also. Two-stage treatment is widely used chemical process to remove, especially complex, to remove phosphate and fluoride. First stage, this C, calcium hydroxide as to raise the pH, leading to precipitation of fluoride as CaF2. Okay. Some phosphate may be also precipitated in the form of calcium 3 phosphate. Okay. Second stage is secondary lime treatment. Additional lime is added to ensure complete phosphate removal by forming calcium phosphate precipitate. Further removal of fluoride may also take place in this stage. Why other ammonia? Lime treatment does not effectively remove ammonia. Ammonia is typically removed through a stripping process. We have seen this thing. Urea is highly soluble in water and does not precipitate with lime. Urea removal requires biological treatment or advanced oxidation process. Arsenic is typically removed by adsorption on iodine and coagulation. Lime process alone is not sufficient for arsenic removal. Okay, conclusion: phosphate and fluoride is only removed. I hope the one who was saying G arsenic, you got it. Arsenic might be produced in. Arsenic might be there in the wastewater, but it cannot be treated with the help of what do I call lime. Okay, coming to the next question, which are the following is the largest water consuming industry? B. Textile industry. Yes. The textile industry use significant amount of water in various processes like dyeing, bleaching, scouring, and washing. It is one of the highest water consuming industry globally. Okay, so in case of textile industry, a huge amount of water is used at each and every stage. That's why a huge amount of water is also produced from the textile industry. Anyone have any doubt? What is the main pollutant in textile industrial wastewater? Main pollutant. C. Dye and chemicals. Dye and chemicals. Yes, the correct answer is C. Dye and chemicals. Textile wastewater contain dye, stabilizer, detergent, and other chemicals that contribute to high pollution level. Many of these pollutants are non-biodegradable and harmful to aquatic life. Which of the government agencies sets the effluent discharge standard for industry in India? Pollution Control Board. Okay, now. So this thing we have discussed also. And can anyone say which is the standard for drinking water? Who sets the what is the name of drinking water standard? Does anyone remember? We have this is general question. Remember, I think if you are appearing for any interview in suppose say environmental thing, anyone can ask which standard do we use for drinking purpose? IS 1050. Yes, that is correct. So that is correct. In India, we see in India we have used, but universally remember we have WHO also. WHO, like those are similar, but generally if someone asks that for India we use IS, that is true, but universally if you read the research paper, uh, it will be like suppose say someone will saying that drinking water limit for this is this much. So in reference you will see two things. One is particular to the that country, that is suppose if I am writing paper for India, then I will be citing two things, that is drinking water limit as per India and drinking water as per WHO. Okay, now generally both are same. There at some there are some contaminant where there is a difference. I don't recall that where is the difference between WHO and Indian standard, but you will always see that if there will be location, then there will be two things. First, this IS code will be there, and WHO drinking water limit as per 2017. Okay, now so I think latest. I'm not aware about the latest version of WHO drinking water limit, but generally you will see WHO drinking water limit as per 2017, and for India in Indian standard it you will say IS 10500 2012. Good. Yes, here also now this was for drinking water. For pollution, like it has four chart. Okay, now first is land, then it is second one is river, Then I think third is ocean, and fourth one is lake or something. Okay, na. So depending upon the degree of treatment, you can discharge your treated wastewater, and that is fully controlled by CPCB, that is Central Pollution Control Board. So the correct answer is CPGC regulates industrial effluent discharge, a standard to minimize the environmental pollution in India. Okay, this was easy question. Which type of fiber is obtained from plant like cotton and jute? The synthetic and metallic bond to be the answer. This yes, yes. The correct answer is cellulose. Cellular dependent plants such as cotton. From where these protein fibers are extracted? Anyone? Animal. Yes. Yeah, correct. Wool, silk. Yes, correct. So here in cellulose, cellulose are plant waste, and yes, correct. Sheep, wool, silk. Yes, silk from silkworm and all these things. These are plant animal waste. So these are protein fibers. Correct. Which chemical is used in we have already seen this. Yes, sodium hydroxide. This was easy question. Involves treating cotton fibers with sodium hydroxide to improve their strength, luster, and dye adsorption. Okay. Which of the following is not a major pollutant in textile industry? Not a major pollutant. We got D. Pesticide. Yes, pesticide is correct answer. These might be contained. So high amount of sodium, high amount of chloride, sodium chloride, high amount of lead will be there. High amount of, but pesticide is entirely different thing. Pesticide is are commonly associated with agricultural wastewater. We have seen that agricultural runoff and all this thing. Okay, that will contain high amount of uh, pesticide. Okay, so the correct answer is D. Which of the method is used to remove phosphorus from fertilizer plant wastewater? Again, this is a repetition of one previous question. Which of the method is used to remove phosphorus from fertilizer plant wastewater? First, we have to remove phosphorus. Where did this activated sludge process is used? Yes, the correct answer is A. That is lime. We know that this when calcium will be added, lime is calcium. When calcium will be added with this PO4, so what will happen that it will form Ca3PO4 whole twice and all this thing, and other form may also produce. Similarly, this activated sludge is used for to treat biological things, biological treatment. We know that in biological treatment process we use activated sludge process. Then we have reverse osmosis for like dissolve generally it is used for heavy metals and all these things, or other also, but it is generally not preferred for phosphorus. Then sand filtration, that is final thing. What is the primary purpose of coagulation in textile wastewater treatment? B. That is reduce color and suspended solid, remove dissolved solid. increase the pH, add nutrients. B. The correct answer is B. Coagulation helps in aggregating a small particle and removing color by using coagulants like alum and ferric chloride. So yes, this was correct. We have to reduce color. For that, we can add these things. Which of the following is advanced wastewater treatment method used in the textile industry? Advanced wastewater treatment method. B. Yes, reverse osmosis is a membrane-based filtration process that removes dissolved solids, dye, and others. So these are generally used for removal of biological things. The settling tanks is, we know that it is not so much advanced. It is normal thing. Generally, settling tank is to remove the suspended solid, uh, certain level suspended solid. So this is not generally simple. Tank will be there, water will be added, and with time all the suspended solid will settle down. Okay. What is the main disadvantage of using activated carbon for dye removal? What is the main disadvantage of using activated carbon for dye removal? C. High cost. Yes, activated carbon is absorption effective in removing dye and organic pollutant, but it is expensive and requires frequent regeneration. That's why, see, frequent regeneration is what, I think, I don't know how it is activated with the help of NOH generally used. It is regenerated. So what happened that this makes thing the whole process very expensive. Okay, so that's why this uh, generally, like, we have to remove the dye, and people are searching for the alternative method that is cost effective also, and efficient is also high. What is the primary purpose of equalization tank in wastewater treatment? This is, if you remember, this was also the question in first lecture. Reduce the inflation flow and pollutant load. Yes, correct. See, we know that we have, when doing a treatment power plant, we have different units. Unit A, Unit B, Unit C. Different have different. Initially, there will be settling tank, then there will be coagulation tank, then flocculation tank, and so on. So each one has a particular capacity, and flow is defined that this not more than this much higher flow should, like, if it has a capacity of to handle x meter cube per liter, x meter cube per hour, then that much volume only should come here. So we know that water coming from different part of city will have different velocity, okay, different flow. So all these are added in a tank, that is on an equalization tank, and from here a defined amount of water is only passed at a particular flow rate. So that's why it removes the fluctuation in inflow and pollutant load. Equalization tanks balance the variation in wastewater flow and pollutant concentration to improve treatment efficiency. Which treatment method is most effective for removing heavy metal from textile wastewater? C. CS electrochemical methods such as electrochloration are highly effective for removing metal without generating excessive sludge. Okay, now here also there will be some sludge production. Here we know that suppose we have solid some and we want to adsorb, then after adsorption it will become a sludge. Then biological treatment, we have also seen that here also a sludge is produced that has to be treated in a separate way. Okay, what is the main environmental concern of AGO dye used in textile? We have seen this. If you have gone through the lecture, this AGO dye is used. What is the main environmental concern? B. They are carcinogenic. Yes. AGO dyes can break down into carcinogenic aromatic amines, posing serious health and environmental risk. Which of the following is a major source of nitrogenous wastewater from fertilizer? This thing is very common. We have seen this thing. Major source of nitrogenous wastewater. Very simple question. Ammonia synthesis. We have seen the ammonium nitrogen during the ammonia unused production, leading to high ammonia and nitrate level in the effluents. Okay. What is the primary raw material used in production of urea fertilizer? C. Yes, correct. We have seen that this ammonia and carbon dioxide react and they form ammonium carbonate, and this carbonate again goes to urea. Urea is synthesized by reacting ammonia and carbon dioxide under high pressure and temperature. What is the name of this process? Anyone? What is the name of this process? A name has been given to this process. Anyone remember it? Haber process. What is the major disadvantage of biological treatment for textile wastewater? B. Inability to degrade synthetic dye. Yes. Biological treatment is effective for organic pollutants but struggle with synthetic dyes that are not biodegradable. Yes, then correct answer is inability, because see these synthetic dyes are do not contain any organic matter, and that's why generally what happen that for textile industry this biological treatment is not so much effective, because we know that biological, and generally if you see, if you have gone through there was very less discussion about biological treatment. There were some in wool and all this thing, wool industry, there was discussion of biological treatment because it contains high amount of BOD CO2 due to presence of plant waste and animal waste things. Okay, na. But due to this presence of dye, this thing is avoided also, because for that we have to do separate kind of treatment and all this thing. Which gas is responsible for eutrophication when discharged from fertilizer industry wastewater? Just answer it, and everyone is saying C. Okay, so C, nitrogen. Yes, excess nitrogen compound such as ammonia and nitrates promotes algal growth and water body causing eutrophication. Apart from this, phosphate also is also responsible for this eutrophication process. What does BOD, that is biochemical oxygen demand, measure in wastewater? A very basic question, and it's not related to industrial. It's related to everything. Oxygen required for chemical reaction or oxygen required for microorganism. Total oxygen contained in the water. Oxygen released by what plant? B. Yes, the correct answer is B. Oxygen consumed by microbes. BOD indicates the amount of oxygen needed by microbes to break down organic matter in wastewater. Okay, so then yes, this is correct answer. B is the correct answer. Okay, now what is the main treatment method for ammonia removal in fertilizer wastewater? This thing we have discussed few times. Remember, ammonia is gas, so is being generally it is easier to stripping. Yes, stream stripping is a process. Explain stream efficient remove ammonia by converting into gaseous state for separation. Okay, so in water it will be in the form of NH4 plus. Okay, na NH4 plus. So generally, what happened that it is stripped down in the form of ammonium. Okay, NH3 plus H plus. Can anyone say why seeing this reaction? To make this reaction feasible, we have to increase the pH or decrease the pH. Suppose if we want to remove ammonium, then you can see that this thing is done. For this, whether we have to increase the pH of the system or decrease the pH of the system. Decrease the pH of the system. If you decrease the pH of the system, then what will happen? If you decrease the pH of the system, then what will happen that more H plus will be there. If more H plus will be there, then reaction will go in this direction. Le Chatelier principle. Do you remember Le Chatelier principle? Increasing, yes. So now if you are saying if you are decreasing the pH means increasing H plus concentration. If you are increasing H plus concentration, then reaction will, as this on reactant side more H plus is there, so what will happen that reaction will try to go on the backward side. So what will happen that you cannot strip down the ammonium, so it's good to decrease, sorry, increase the pH. If you increase the pH, H plus concentration will get decreased. H plus as H plus is getting decreased, then so as per Leach principle, this reaction will go in the forward direction. Okay, now so the correct answer will be increase the pH of the system. I hope you have got it. No need to say sorry. I'm not here to do anything. Okay, so I hope this is or which element in fertilizer wastewater is highly toxic to fish and aquatic organism? We have already, this is fourth time this question is coming. Fluoride is toxic to fish and can accumulate in water bodies affecting aquatic life. What is the primary advantage of using electrocoagulation in textile industry? Disadvantage. In electrocoagulation, there is no sludge production. They are asking primary disadvantage. Oh no, sorry, sorry. You are correct. This is electrocoagulation, not electrochemical. So there are two things: electrochemical process. Okay, na electrochemical and electrocoagulation. Remember last time we were discussing one question which was about. Uh, Let me open that question. That was about electrochemical. Where did it? Are you able to see electrochemical question? There is two process. Means I also read the question in incorrect way. Okay, na. So that's why main advantage of extreme. Just wait for 1 minute. So I will hold on to this question. I think I have to recheck the class notes. Okay, now miss there is something wrong. What is the primary disadvantage? But generally in electrocoagulation process, a less amount of uh, sludge is produced. Limited to. Okay, just I will discuss this thing in next lecture. Okay, now just remind me. I will also note it down. Okay, I think this question might be like none of these option is incorrect. Okay, na it requires no energy output. That is itself is incorrect. High sludge production, limited removal of heavy metals. That is also this is most of the heavy metals are removed from electrocoagulation. Ineffective for dye removal. This can be one of the answer. Like generally it in that all some challenge is being faced in dye removal. So I think B might be the answer, but I'm not sure. Okay, na D might be the answer, but I'm not sure of now. Okay, na. So I will discuss this thing in the next lecture. For please hold on to this question till next time. Which textile wastewater component is the most resistant to biodegradation? B. Anthracene dyes. Yes, anthraquinone dyes have fused aromatic structure that make them highly resistant to biological degradation. That's why this biological treatment method is also not suggested for this in this textile containing dye and all these things, because this cannot be easily degraded. What role do surfactants play in textile wastewater pollution? First question is, what is surfactants? Anyone? Reduces surface tension. Yes, correct. Yes, reduces surface tension. That's correct. The B increase they increase the COD and toxicity. Yes, the surfactants used in processing contribute to high COD levels, because see, generally surfactants, if you have seen, it is organic, long chain of organic molecules and all this thing. Okay, na. So, so what will happen that eventually it is like, if we want to degrade all these things, we require high amount of, and also these are not degradable and all this thing. Okay, na. So what happened that if we want to remove it, we require more oxygen and all this thing, and we know that if something is increasing this oxygen demand and all this thing, then that is terms at chemical oxygen demand. If it would had been or degradable organic compound, then it would be have been biological oxygen, biochemical oxygen demand, because in that case microorganism can consume those biodegradable organic matter, and whatever the amount of oxygen required by the microorganism will be each term in the sense of BOD. But when we are talking about overall, mostly where there is a non-degradable organic compound, then at that point we talk about this COD thing. Okay, na. And these surfactants are generally, if you like seen, this type of long chain polymer will be, long chain some molecule will be there. And how the correct answer is reduce surface tension. How it reduce the surface tension, that is another thing. Okay, na. So in brief, like, it attaches to the surface and all this thing, and it changes the surface property. But if you want to look into the more, I will go. I don't have any book to suggest, but you can always check on internet. Okay, na. But generally, if you check the definition of surface surfactant, the uh, molecule or something which reduces the surface area or alter the surface area, surface tension, is known as surfactants. Soap is also kind of surfactants and all these things. Which of the following chemical is used as reducing agent in wet dyeing? A. Hydrogen peroxide. No. Sodium hydrosulfide is the correct answer. So, sodium hydrogen sulfide reduce the wet dye into soluble form of fabric dyeing. Okay, na. So right now I don't have option about, but if you for this I will open this. Just wait 1 minute. I will open the lecture notes. I hope you are able to see my screen. Wet dyes require caustic soda and to reduce the what was the question? Huh. Right. Hmm. So if you just so here you can see that vat dye require caustic soda and sodium hydrosulfide. Okay, now so caustic soda is NOH. Okay, now so I think uh, uh, hmm, it will have two answer. Okay, no, not one answer. C and B and C. B sodium hydroxide and okay now I don't know why did you say hydrogen peroxide. Hydrogen peroxide. Hydrogen peroxide you can see it is used in bleaching operation, not in dyeing operation. Okay now it oxidizes. You can see peroxide such as in cotton, see see this in bat dye only required, but this use of peroxide is for different thing. This is oxidized after once soluble forms are made, then it is oxidized. Okay now for fabrication, in that case this peroxide is used. But if we are talking particularly about this vat, then here you can see that this caustic soda and sodium hydrosulfide is used. Did you get it? See here, hydrogen peroxide is used for bleaching purpose. I hope you have understood it. So, what is the main reason of using fertilizer? This thing I have already answered it. This is repetition to ensure uniform pollutant load. Why is reverse osmosis not always suitable for treating industrial wastewater? Anyone? A. It requires high pressure and energy. That's correct. Explanation. RO is effective but consumes high energy and requires frequent membrane maintenance, making it costly for large scale. Okay. So this thing we have already. What is the primary source of high BOD in wool textile mill wastewater? This is simple question also, but what is the primary source of high BOD? B. Wool grease and detergent residue. Yes, correct. Because this see BOD, when we are talking about BOD, it should be biochemical. Okay, now this chromium is fully inorganic, no relation to BOD. Sulfuric acid again fully inorganic. Sodium sulfite is fully inorganic. This wool will contain some amount of organic matter which will be as it is wool waste. Okay, now so it will contain wool, sorry, animal waste, protein waste, which we are talking. Okay, so it will contain high amount of BOD. Wool's scoring release high BOD due to grease, fats, detergent residue. Okay. See, this detergent residue might not give contribute to this high BOD, but this will contribute to high BOD. Okay, now this detergent BOD may also, but if like what is the like we know that there is two parts. One is cation part and anion part. How this anion part is there, so that is entirely different thing. These are following unique pollutant in wool processing wastewater. B. Yes, is a natural wax present in a raw water that get released into wastewater during scouring. Okay, now. So this we have seen where this is fluoride is generally phosphate, then lead, zinc. You can see the sources of these pollutant. Zinc we have seen. Can anyone say where this zinc is produced? We have discussed this question few minutes ago. In which industry this zinc is viscose? Yes, we have seen that this zinc sulfate is used. Okay, now there was one question, na zinc. Mhm. Yes, you can see here. Correct. In here, this zinc sulfate is used. That's why a huge amount of zinc is produced. Where were we? Huh. Coming to the this carbonizing involve which chemical treatment? Which chemical? Whether acid is added, whether base is added, or bleaching is added, or oxidation is done. First, remember what is carbonizing. Itself, carbonizing definition itself suggests that what we have to do. So answer lie in that in acid treatment. Yes, correct. Acid treatment. Why concentrated sulfuric acid? This was, remember, like we have to remove the extra. Suppose extra something extra is there, then we can remove it. In biological treatment, what is the purpose of nitrification? This is simple question. The question, there is only one correct answer. There is no relationship between this nitrate BOD and nitrate. Okay, no. Do you know what is this? Can anyone say, is there any relationship between BOD and nitrates? Yes, correct answer is A, but I am asking a different thing. Okay, now does BOD have any relationship with nitrate or not? Can anyone do anyone recall remember what is this BOD? Means basically biochemical oxygen demand. But I am saying that does it have any relation? Yes. How? You can unmute yourself and you can speak if you want. or you can type also, whatever suits for you. You have said yes. I am asking how. Okay, like if you are saying yes, then I hope you are say remember. See, there is two thing. If your organic matter, na, generally it is in form of C, X, H, N, and all this thing. Okay, na. So now what will happen that when there is a organic matter, na, suppose this microorganism is there, so it will consume this microorganism on this whole organic matter. Okay, na. So what will happen that first, what will happen that this carbon will be getting converted into CO2. Okay, so for that some oxygen is required. Then again this nitrogen will also getting converted into some form, maybe NO2 or NH3, it depend upon various thing. But for this conversion of nitrogen also, there is a requirement of oxygen. Okay, na. So generally what happen that this is known as, so when oxygen is being demanded only for conversion of carbon, then it is known as carbonious COD, carbonious oxygen, carbonious biochemical oxygen demand. But when this oxygen is required for nitrogen purpose, then it is known as carbonious, nitrogenous biochemical oxygen demand. So this is like BOD has two parts, always two parts. Okay, now there will be carbonious BOD and there will be nitrogenous BOD. So like what happens that generally within if you have seen this BOD curve is there, so generally this type of curve is drawn. Okay, now so and this flattening is happening at between 5 to 7 days, 5 to 7 days. Okay, na. So this is time and this is amount of BOD. Okay, na. Not BOD. What is this line? I don't recall. But generally, what happened that within 5 days, all the carbon will be getting converted into CO2 and all this thing. Okay. Yes, by microorganism. This Oh, sorry, you have written something else. But I'm saying, see, so within 5 days, what happened that all the carbon is getting converted into COD, and within after 5 to 7 days, all the nitrogen will start getting converting. For that, we have another thing that is nitrogenous. Um, for that we have nitrogenous oxygen biochemical oxygen demand. So yes, there is if there is will be nitrates also. So first for that also, for that conversion also we need some kind of oxygen. I hope you have understood it. I forget what will be on the y axis, but it's something like this only. Okay, coming to the next question, what is the major environmental concern in viscose iron manufacturing wastewater? This thing we have already discussed, high zinc and sulfide levels. Okay, which factor influence the efficiency of electrochemical treatment in wastewater? Try to answer this question. Which factor influence the efficiency of electrochemical treatment in wastewater? Yes, C. Current density and reaction time. Higher reaction density and longer reaction time improve the electrochemical treatment efficiency. Okay. Which process in nylon manufacturing generates wastewater? Answer this question. Which process in nylon manufacturing produces in manufacturing generates wastewater? C. Are you saying for this? C. Dyeing. Yes. While polymerization on land generate much liquid, dyeing and finishing contribute to wastewater. That's true. C was the correct answer. Which byproduct is a significant pollutant in phosphoric acid production? So first you should know that how this phosphoric acid is being produced. Which byproduct is significant pollutant in phosphoric acid production? Anyone? Gypsum. Yes, gypsum is a generated byproduct. Remember why gypsum is produced. So if you recall how phosphoric is produced, generally fluorapatite is there. Ca5, PO4, PO4, whole thrice, F. F is there. Now it is dissolved in sulfuric acid, that is H2SO4. So what will happen that H2 actually H2SO4. So what will happen that this calcium and sulfate will react and it will form gypsum. So this is a byproduct also. Okay, na. This thing is also I think it is in your notes also. Phosphoric acid. Here you can see gypsum. This phosphate rock is it's written in different form. Okay, na. But like phosphate rock can be anything now, but fluorapatite can be there, this can be there. So you can see this is reacting with H2SO4, and this calcium and phosphate is reacting to form gypsum. Okay, so this is a byproduct. I hope you have understood it. Hmm. What is the purpose of using alum in coagulation flocculation? Very good question. Not good question, but very random, general question. What is the use of alum? If you are continuously attending my session, then I have said something about this thing. What is stabilize and destabilize? Yes, the correct answer is C. That is destabilize. Alum neutralizes neutral by allowing them to clump together for easy removal. Okay, na. So generally the concept is this thing that. Mhm. Concept is that first there will be settle it will be passing through mm, uh, first water will be wastewater will go into the settling tank. Here what will happen that all the settling solid will settle, but there will be some solid bit will remain suspended. Okay, na, suspended solid. So due to their lightweight or some other property, it won't be getting settled, so means they are very stable. So we have to stabilize destabilize it. For that we add coagulant, and one of the common coagulant is alum. Okay, now so as we add, what will happen that it will forms a clump like a structure. Its weight will increase and it will finally settle down. What is the main environmental impact of fluoride in fertilizer wastewater? Environmental impact. B. Yes, lead to bioaccumulation in aquatic life. What does it cause to humans? High amount of fluoride, what does it cause? Can anyone answer it? if we start drinking water containing high amount of fluoride, what will happen to us? Human. Effect in teeth. Okay, yeah, that's correct. Effect in, see now, like effect in teeth generally happen to also bone. Yes, bone is more accurate answer. It will start like if we are talking about adult people like us, then it will generally our bone will get. But if a small children is drinking high fluoride content, their teeth and bone both will get disturbed. Okay, na, like yes, correct answer is both thing. But at what age which part will get defected by high amount of fluoride, it also depend upon your age also. So in general you all guys are correct that yes, both decay skeleton fluorosis, generally we say dental fluorosis and skeleton fluorosis, two things is there which is caused by high amount of fluoride consumption. Correct. What is the drinking water limit of fluoride? Last question. Anyone know what is the drinking water limit of fluoride? Uh, oh, you are going. This is Fenton. Okay, which of the following oxidation process is most common in textile? Yes, Fenton reagents, hydrogen peroxide plus iron catalyst used for breaking down the organic pollutant in textile effluent. Yes, this is correct. What is the most effective treatment for removing phosphates from fertilizer removal? This is with this thing we have also talked. This chemical precipitation with lime. No need to discuss it again. What is the primary concern with the disposal of sludge from textile wastewater treatment? What is the primary concern with the disposal of sludge? A. High disposal cost. See, we have lots of money. People have lots of money. Not in the sense lots of money, but yes, this that is also concerned that high amount of. But if you have see only each and r each only each there. If it would have been each and r, then I could have asked marked A and B both thing. Okay, na D also. Maybe all of these are a concern, but primary concern is that this textile wastewater contains a high amount of toxic heavy metals such as zinc, chromium, lead. We have seen this thing. Okay, na. So the correct answer lie between in the language of this question. Okay, the question is simple, asking for single correct, and single correct is this presence of toxic metals. Which type of nitrogenous fertilizer in have highest ammonia content? B. Ammonium nitrate. Urea plant wastewater. See, ammonium nitrate, these are raw material, I think. If you have see here, you will see nitrogenous. Uh-huh. Manufacture ammonia. See, ammonia is the raw material. Okay, na. So ammonia is a raw material. Ammonia comes in the form of these kind of salt. Okay, now so now these are getting converted in ammonium, like ammonium and ammonium nitrate, ammonium sulfate. These are some of the raw material. Let me show you the reaction. Okay, now the ammonia synthesis of nitrogen Haber's process. We have seen this thing. Firstly, H2S, then see liquid nitrogen is pumped into the, see, but you can see that this. Ammonium sulfate or ammonium chloride, the ammonium nitrate is itself is a different thing that has nothing to do with you can see here, read about the manufacturing of ammonium nitrate and all this thing. And if you read the question, it is asking which of the following nitrogenous fertilizer have highest ammonia content. Okay, na. So there will be a list also. I don't know. Let me see there must be a table. You have to see, look it into here. Okay, na. Wastewater from fertilizer. Most of them production of ammonia. Not a raw material, but see, all three of them will contain some kind of ammonia. But highest amount of material mixing file. You have to go to the lecture notes for seeing that how much ammonia is in each kind of fertilizer. Okay, na. But if you look in the nitrogenous, it will contain highest amount of urea, sorry, highest amount of this thing, mm, um, highest amount of ammonia. Are you getting what I am saying? Just tell me yes or no. See, I'm not getting that table. I don't think there is a table, but somewhere it is written uh, that this contain highest amount of ammonia. You can always go to you can always look into this thing also. Impact of receiving treatment of fertilizer, wastewater, two stage treatment. Okay, I'm not getting it, but generally what happened that this type of this urea waste will contain, because it is directly being produced from urea. But if you look at the production of ammonium sulfate, it is entirely different thing. Okay, na. So so correct answer is C, urea plant wastewater. Okay, now this is the last question. And if you are attending my session, then this is the like fourth time that I am giving this type of question. There is no numerical question in this topic, but still I have made one numerical question. So try to solve it. A textile mill discharge this much of wastewater with BOD of 800 milligram per liter. The BOD permissible discharge limit is 50 gram per liter. If the treatment system removes 90% of the BOD, determine the BOD concentration in the treatment effluent, whether the treatment meets the permissible limit, and the total mass of BOD removed per day. Take your time. We have 10 minutes. I will give you 2 3 minutes. 4 minutes. By 54, it is 50. By 54, just answer A, B, C. A will be some numerical term, B will be yes or no, C will be some numerical term. Take your time and solve it. Everyone, I request everyone, this is numerical question, very simple numerical question that we have solved around 3 or 4 times. Already solved 3 or 4 times. 80 milligram per liter. So if 80, then B will be no. That's correct. What about C? The total mass of BOD removed per day, 7200 kg per day. Let's see. Yes, so the first one was correct. 80, like initial BOD into removal efficiency. Then 1 minus 0.9, then that is 80 milligram per liter, and as permissible limit is 80 milligram see, permissible is 50, but your treated effluent has still 80 milligram per liter, so that's why it will be no. And the second part is removed 72 milligram per in being removed, and you know the flow per day, how much flow is coming, so you will multiply it and finally you will get it 7200 kg per day or 7.2 ton per day. Yes, correct. Ne aage itte. Good. I hope everyone has solved it. See, the question was simple, very simple. Just you have to multiply it. This much meter cube is equal to this much liter. Then liter will be multiplied. Liter get cancel out, and here the unit is liter per day. Okay, na? So that's why milligram per day, and this 10 ki power 6. This much will be into kg, and finally we have 7200 kg per day. Anyone have any doubt? This was the last question. Again, I am asking for the last time. You have there were three assessment where you did not get your marks. So did you get it or not? Yeah, still that is in pending mode. Do I need to mail them again? Yeah, the problem has been solved. Okay, so only three sessions are left, 10, 11, 12. So make sure that, okay, not yet. Not yet. Okay, then not yet, then I will mail it again. Okay. Just when you come to the next lecture, remind me on this at the start of the lecture. Okay, na I will mail it by tomorrow only. Okay, na. But still make sure that you remind me if your problem has been solved or not. Okay, that's all for today. If you have any doubt, you can ask now, or we can end the session. If anyone have any doubt, you can ask. I have where did I have doubt in one question in the week in this week assignment. Okay, what is the let me open the this thing. Just wait for 1 minute. Let me open the assignment. Okay, which question? Fifth one. What is the primary environment concern associated with the wastewater produced during production of synthetic fibers? High level. There was similar question related to this thing, na? What is the doubt here? As per lecture material, it is A. As per lecture material. But why not B? See, microplastics and all these things are different things. Why would you say microplastic? Do you know how microplastics are produced? Hmm? Just let me show you something. Just tell me how microplastic are produced. What do you mean by microplastic? Yes, means like what is your answer? I don't see. The center. Yes, you are correct. So also but why not be as per lecture material? No, I don't think as per lecture material it is A. I was going through the lecture notes only. The correct answer will be B only. Presence of microplastic and chemical solvent. Yes, the correct answer will be B. Just let me. See, the correct answer will be B. In synthetic, we don't have this thing. What do I call? Nitrogen material. From where did you? From on which slide did you see that it will be A? Synthetic fibers are nothing but yes, the synthetic. Yes, you are correct. It will that will be in form of micro or nano form. First, tell me where did you see this thing that A should be the answer? I don't think anywhere it is written that for synthetic one. Lecture 3, first page. Lecture 2. Lecture 3, first page. Synthetic high amount of total solid. They also contains large amount of entirely of organic in nature. And what is the question? Question is what is the environmental concern? See now this thing is like may contain. Wastewater also contain a large amount of nitrogen, entirely of organic nature. I think see it might have some other meaning, but it's I think if I have to mark it, I will marking it B. See this why I won't be marking A because see this nitrogen is not problem from synthetic. It is a major concern due to uh, fertilizer industry and all this thing. Okay, na. So now if I have to choose between A and B, so your statement itself stand that yes, this here you have written synthetic fibers are nothing but a plastic fibers in micro or nano form. Okay now, so I will be more focusing on these, because you see now if you compare two industry like fertilizer industry and this synthetic industry, both of them will contain nitrogen. Now which is giving more nitrogen problem, this are you getting what I am saying? Like try to compare. What about nylon 66? What about nylon 66? Where does it comes from? uh, Nylon 66 means it is in, what is see this might contain nitrogen, but it is not a major thing. You have to look into the major thing, like which is giving the majority of the pollutant. Okay now, yes, it might be correct that this nylon 66 might contain nitrogen and all this thing, but does it mean that due to the wastewater generated from this will give a majority of nitrogen? Like there is see there is two things, microplastics are also coming and this nitrogen containing compound is also coming. But if you compare the threat level, this microplastic will have more threat as compared to this nitrogen thing. So that's why as you have to choose one thing, as you have to choose one thing, like which is the which is the primary concern, then I will be choosing this presence of microplastic, because the presence of high level of nitrogen is generally from the fertilizer and all this thing. Like if you have to say, suppose this question was this type of question, like write a difference between wastewater produced from synthetic fibers and wastewater produced from fertilizer, and you have to write only one difference. Then for fertilizer you will be writing that it contains high amount of nitrogen, and for fiber you will be saying that it contains high amount of microplastics. Did you get it? Anyone have any other doubt? Mark B. I think B will be the correct answer. If something will happen, I will take care of it. Okay. Apart from these, I think these are very simple question. Most of the question has been discussed today. See phosphate here. See now here you can see now here you will be applying this thing 2:1. I'm not going to do this thing, but I hope you have got it. Anyone have any other doubt? Else not, then I will be ending the session. Okay, so and for next week I will be taking the session on Wednesday. That is on 3rd of April. You will get notice. We won't be meeting on Tuesday. Okay, now we will be meeting on Wednesday. I will send you the notification, but I am announcing also because I won't be available on Tuesday. Okay, so thank you for attending my session and do join as per the notice, as per the notification given to you. Thank you. Good night.